Today, we'll be solving LeetCode 104, maximum depth of binary tree. This is a foundational problem that helps us build intuition around binary trees and recursion. We're given the root of a binary tree, and our goal is to return its maximum depth, which means the number of nodes along the longest path from the root down to the deepest leaf. As shown in example 1, we can see that the maximum depth is 3 because the longest path from the root passes through 2 more nodes before reaching the end. That makes 3 levels total. Other branches might stop earlier, but we care only about the longest one. Now let's talk through the idea behind the solution and walk through the code at the same time. We'll use recursion to solve this. The key idea is simple. The maximum depth of a tree is 1 plus the maximum depth of its left and right subtrees. So we start by checking if the root is null. If it is, that means there's no tree at all, and we return 0. This is our base case, and it helps the recursion know when to stop. If the root is not null, we move on to find the depth of the left subtree. We do this by calling the same function on the left child of the root. Then we do the same for the right subtree by calling the function on the right child. Once we have the depth of both subtrees, we compare them. We take the larger of the two, because we're only interested in the longer path, and then we add 1 to include the current node itself. That's it. This approach is clean and effective, and it mirrors how a tree is built from the bottom up. Let's now go over performance. The time complexity is O of n, where n is the number of nodes in the tree. This is because we visit every node once. The space complexity is also O of n in the worst case, due to the recursive call stack. That happens when the tree is completely unbalanced and forms a straight line. In a balanced tree, the space complexity would be closer to log n. To wrap it all up, this problem is a perfect introduction to solving recursive tree problems. We used post-order traversal, handled a clear base case, and combined left and right results in a meaningful way. These are patterns you'll see again and again in tree questions. And that's how you solve LeetCode 104, maximum depth of binary tree. Thank you for watching, and let's keep learning.